My talk today will be on my work at the Indus tradition site of Harappa, working on the copper and bronze metal remains. Before I get too much further, I'd like to thank a variety of people. There's far too many to list on the slide here, and none of the research I present today would have been possible without the assistance of the directors of the Harappa Archaeological Research Project, the support of the Department of Archaeology and Museums, Government of Pakistan, my colleagues at the Department of Anthropology, University of Wisconsin-Madison. I should specifically mention Dr. Randall Law, and a variety of other people. Finally, I would like to thank the conference organizers for including my contribution to this important web seminar. So what I'd like to talk to you about today is the research on the use, production, distribution, and source points of copper and bronze artifacts recovered during the excavations by the Harappa Archaeological Research Project at the Indus civilization site of Harappa. I'm primarily going to focus on the urban period of the integration era, looking at the Kotdiji or early Harappan phase and the Harappan phase. This is where the primary component of the copper and bronze assemblage dates to. One of the things I should mention before I get much further is status and wealth in the Indus look a bit different than we're used to in other contemporary third millennium copper and bronze using societies, such as Mesopotamia, Egypt, sites in the Gulf, is that we find burials containing simple or no grave goods. We don't have iconography as elites, as warriors or conquerors. And this is a contrast, as I mentioned, with other early states in the region. And these other areas that used metal appear to use metal in a different way, something I'll touch on later in the talk. If we turn our attention to how metal was used in the Indus, we see it used to make a variety of forms, ranging from utilitarian things such as cooking pans to cosmetic containers, scale plans, decorative mirrors, and these incised tablets at some of the larger sites like Mohenjo-daro and Harappa. We also see a variety of tools and weapons. And we see copper and bronze being used in elements of personal ornamentation. In fact, other than clay or ceramic, I'm not aware of a raw material that was used in the Indus to make a higher variety of forms of artifacts, forms of final finished objects. What we see is that there's also a continuity, perhaps, in a regional level through time. And while this isn't a big focus of my talk, I thought I would just mention it. And it's always been striking, these images of Indus copper cooking pots that appear to be replicating forms seen in ceramic and appear to be hearkening to and related to, at least in a morphologic way, to modern metal cooking pots as well. Many of these images, I should say, have been shared with me by my colleagues, particularly Dr. Mark Knoyer. He shared this image with me of an anvil for shaping copper vessels at a contemporary workshop in Oman, and this possible copper anvil that's been reported from Dolavira. So we may see a continuity of regional traditions that stretches back into antiquity. Returning specifically to the Indus copper and bronze metallurgical tradition, it's traditionally been described as far less complex than Mesopotamian metallurgy. Some of the earliest investigators of the Indus civilization were trained, did lots of work at Mesopotamian sites. They contrasted the metal they were seeing at early Indus sites like Mohenjo-daro and Harappa, and they felt that it wasn't as complex, it wasn't as well formed. It was termed an incomplete development of the Bronze Age. And this, I would argue, is based on incomplete models of metallurgical development. Outmoded models. There was this traditional interpretation that you needed to have copper be completely replaced by tin bronze, classically what we refer to as a bronze, to be a fully formed Bronze Age society. What we see in the Indus, however, is a different pattern. And we see this in other societies as well. And what many people working on ancient metallurgy have transitioned to is that a Bronze Age exists when a society is capable of making bronze alloys with several alloying alloying elements, and that will also exist alongside the continued use of unalloyed copper. As I mentioned before, the Indus is contemporary with several other old world states. What's important about this is that the Indus was interacting with all of these areas. And although the Indus represents its own indigenous development, it had economic and resource and social and political and all kinds of other interactions with a variety of other neighboring societies in adjacent regions. What's of interest for me about that is a variety of areas here mentioned on this map all use copper and bronze. And we can see relationships in how this metal was used and possibly see how metal was being moved around between all of these areas. As I mentioned earlier, it's important to differentiate how metal was used in some of these societies. I'm drawing a generalization here, but in societies other than the Indus, such as Mesopotamia, Oman, societies across the Arabian Peninsula, such as those in Magan and Dilmun in Mesopotamia, again, as I mentioned, Egypt, we see metal being used in elite context of very frequently to make fancy bronze materials. Oftentimes these materials come to us through the archaeological record of tombs and burials and palaces. Again, something we don't see in the Indus. Turning specifically to Harappa, I was fortunate enough to be able to work there, and I wanted to investigate how copper and bronze was functioning in the Indus, but using Harappa and the archaeological record there as a platform to understand and model it at Harappa, and then see if that could be used and applied to other Indus sites. So I came up with a series of research questions, and I will try to highlight the results of this analysis to these questions today. Where was the copper distributed at Harappa? What are the patterns of alloy use? Is there evidence for production of copper and bronze items actually on site? And then finally, regardless of where the items may have been produced, where did the raw materials to make the copper and bronze artifacts from the site, where they obtained from? One of the first things I did is I wanted to look at what had previously been analyzed, what had previously been discussed about Indus copper and bronze metallurgy. So I looked at all of the published compositional analyses I could find from any Indus civilization site in the record. And what I found is that there was more bronze than previously thought, and there was actually a complex pattern of alloy that contrasts sharply with some of the earlier investigators' report of an incomplete or unfinished Bronze Age. Looking at the published excavation reports from sites such as Harappa, Mohenjo-Daro, Nepal, and Sokotra, you can see that tools and ornaments make up the majority of the copper assemblage. If you update the number of alloying elements to go beyond tin, and you add lead, arsenic, lead, arsenic, tin, and then mixed alloys that have all of those elements into one discussion of all of these things have an intentional addition of another element to make a bronze, an alloy of some other element with copper. You see that copper alloys make up almost half of the assemblage. The original ASI report said that only just under 30% of the reported analyzed assemblages were identified as bronze. We see that in more recent analyses, these analyses have all been conducted since the 1980s, we find it two to three times more frequent identification of some sort of alloy, copper, or bronze. And I think what we're seeing here is not that there was flaws in the ASI analysis, it's just that in the intervening decades, chemistry and our ability to measure these things became much more precise and much more accurate. And we were able to document a change, or document a shift in these frequencies through more sensitive and analytical techniques. As a result, we need to shift our discussions about Indus copper and bronze metallurgy to realize that there may be copper alloys or a predominant form of the assemblage, rather than the assumption in the traditional interpretation that Indus assemblages are dominated by unalloyed copper. Specifically at Harappa, there are just over 2,400 objects that have been excavated that fall into the category of copper and bronze artifacts. These artifacts can be divided into 15 categories. Of these 15 categories, you can then group them under two major headings: tools, depicted on this chart in red, and objects of personal ornamentation, depicted on this table in blue. In terms of the distribution of these materials at Harappa, this is the map of the excavation units by the Harappa Archaeological Research Project, and based on the records from that project, we can see that in every excavation unit I think except one or two, there's been some number of copper or bronze artifacts recovered. So we see that metal materials, at least copper and bronze metal materials, are distributed widely across the site and don't appear to have a major difference by spatial unit at the site or by sector. The next thing I wanted to do was do some chemical analyses on these variety of these artifacts. I was fortunate enough to get permission to do this, and categories in orange have been investigated for both their elemental composition and for their isotopic signatures. Areas in green have just been investigated for isotopic signature, and purple for composition only. To date, roughly 230 artifacts from Harappa have been analyzed for composition, and about 130 have been analyzed for their isotopic signature. So I then needed to pick a series of benchmarks to define what was an intentional alloy. In other words, what was an intentional addition to copper by people in the past to make a bronze or an alloy. I chose these levels depicted on the slide: arsenic at 1%, lead at 1%, and tin at 2%. These were based on a review of the literature on what percent composition represent an intentional addition by people. If you use these benchmarks, one can identify 6 alloy types at Harappa. This is in addition to the traditional tin alloy or bronze, we can add a lead alloy, an arsenic alloy, and a variety of multi-element alloys. Once you investigate and categorize all of the alloying types available at the site of Harappa in the artifact assemblage, 2 broad trends emerge. The first is decorative objects such as rings and bangles and beads appear to be consistently manufactured from specific copper alloys. For instance, bangles and discs are manufactured from copper and tin. Rings and beads are manufactured from copper and a range of alloys. These provide the final product with a variety of visual appearances. In contrast, utilitarian items such as arrow points, rods, and blades, things that would have been made of tools, are manufactured from a wide variety of copper alloys. This includes many multi-element alloys. And what I believe is going on here is these objects are manufactured with an idea of the final product having a functional purpose. And they're made from a wider range of alloys because if you add lead or arsenic or bronze or tin, or a combination of things to the copper, you provide the same end result as you get a stronger, more durable tool. And it did not matter what its visual appearance was. One of the ways that I'm convinced that this trend was intentional, and it was something that resulted from the actions of ancient Harappan smiths, was if we look at rods and bangles. They're manufactured through similar techniques, and they demonstrate starkly different alloying patterns. There's potential evidence for the manufacture of both on site, so I believe that this helps substantiate the idea that alloying use and a specific alloy selection was a decision based on the desired final product and not based on technology of manufacture or restrictions in supply. Finally, we have a category at Harappa called prills. These are seen as proxy markers of production. They're spillage from casting and melting. They're waste bits of copper that then go into the archaeological record. And all of the identified copper alloy types are seen in the category of prills. So this could indicate a variety of production methods being used on site, and again, indicating a intentionality in alloy selection and alloy production. So we've analyzed 25 of these, and all of the alloy types identified are present in the prills, as I mentioned before. There is other evidence for copper and bronze production on site at Harappa. It was traditionally the Indus has a smelting versus melting model. In other words, on sites like Harappa, melting of copper and bronze, already processed raw materials, was taking place. There was no smelting of ore. And oftentimes the evidence from Harappa backs this up, that molds may have been used. You can see here one of Dr. Kanoya's replicative experiments using sand molds. I also here used the work of Dr. Heather Miller from the site of Harappa to indicate the presence of small scale production based on the use of ingots and other raw materials, but not the smelting of ore. However, in 2009, 2010, this large piece of material that looked to be made of somewhat of copper fell out of the Harappan layers at the trench on Mound A-B. When this thing was analyzed, we see that it has all of the elements of a metallic slag phase from the smelting of copper ore, pictured here in green. What this lump can be classified as is a slag then from high temperature smelting and processing of copper ore inside some type of furnace assembly. If we map out all the manufacturing debris, we have ores, we have slag, we have vitrified ceramics and mold fragments, we see that there's a possibility that copper production was taking place at multiple locations across the site of Harappa at a scale that has previously not been recognized. So looking at the first few research questions that look at copper and bronze consumption and use at the site, we see that there's an even distribution of materials across the site with no restriction in access to either artifact type or alloy category. Tools were made from alloys that were selected for their function, with little or no consideration of the final visual appearance of the artifact, but just that it would work and accomplish its purpose in an efficient and proficient manner. Ornaments, in contrast, were made with a much more selected categorization of alloys, specifically directed towards final visual appearance. This final visual appearance would have enabled these ornamentation items to function in status and wealth hierarchies of artifacts within the Indus civilization. Finally, I believe that we see the use of multiple sources for copper raw material at the same time at the site of Harappa. And this is through measuring the isotopic signature of a variety of artifacts from the site and then contrasting it with a geological database. Lead isotope analysis measures the 4 isotopes of lead. The ratio of each isotope does not change between the ore and the final artifact, regardless of what happens to that ore between the time it was mined and the time the artifact is analyzed by the researchers. So whether you heat it up, melt it, put it in the ground for thousands of years, you do not change the ratios of these isotopes between the ore and the final finished product. With the assistance of many colleagues, particularly Dr. Randall Law, I was able to compare artifacts from Harappa to a variety of potential 3rd millennium BC copper source areas. What I'm going to focus on primarily in this talk is the source areas within South Asia, and then a comparison to artifacts from Oman and Mesopotamia. All of the areas that were used for potential comparison to the artifacts from Harappa were based on previously done research, primarily by Law and Knoyer, documenting and identifying interaction networks that were known to supply the site of Harappa with raw materials. Overall, the artifacts from Harappa demonstrate strong isotopic correlation with sources in Baluchistan, Waziristan, and Rajasthan. There is limited correlation with sources in other adjacent regional copper producing areas. I want to focus first on the correlation with items from the Aravalli range in Rajasthan. We can group the incredibly rich and diverse copper deposits in this region into geographically related sections. We can come up with sections of the North Delhi Fold Belt and the South Delhi Fold Belt and a few other belts, but I want to concentrate primarily on the South Delhi Fold Belt and the North Delhi Fold Belt. You can see these pictured on the map here. If you plot these materials on a traditional lead isotope graph, I'll promise I won't do too many of these. I know the scale is hard to see, but just bear with me. These circles represent geologic copper sources. The red triangles represent artifacts from Harappa. I'll draw your attention here to the artifacts that fall in this area and the artifacts that fall in that area. Those two areas represent the South Delhi Fold Belt and the North Delhi Fold Belt primarily. just under half of the artifacts analyzed from the site of Harappa appear to correlate isotopically with copper sources in those two fold belts. When we look at it by alloy category, we also see a predominance of the assemblage falling within those two belts. So what this appears to say is that if we look at the northeast, which is the polymetallic copper deposits around the Khetri region, we seem to see a correlation with some of the Harappa artifacts. We also see Harappa artifacts correlating with deposits around the Assemblage dairy area. What we don't see in the HARP assemblage is any isotopic correlation with copper deposits around central Rajasthan. This is primarily the Rajpur Dariba area. One of the things that is fundamental to lead isotope analysis is essentially what the numbers are telling you. They're telling you how old is the geologic formation that the copper metal, the ore that is being mined, is hosted in. So you're essentially getting an age. The Aravalli deposits are very old rocks, between 1 and just under 2 billion years ago. This creates a series of light isotope ratios, and you can see that in this box here, this distinct area. And what's interesting is this may be functioning as an Indus lead isotope signature. In other words, if you get a copper ore or a copper artifact or a bronze artifact that falls within this range of isotopic ratios, it is more than likely sourced to the Aravalli. And I'll return to that in a bit. I want to look at sources in the Pakistan side of the border now, in Balochistan and Waziristan. Again, I realize this graph is hard to see, but just bear with me and I will highlight the key areas. You can see a group of objects, artifacts from Harappa, that fall in this area between sources, this source area and this source area. This is the end of the North Delhi fold belt. This is Waziristan and this is Balochistan. And we have a class of artifacts that fall right here. It's roughly a third of the analyzed assemblage from Harappa. And what's interesting is there was less variation in these 40-some objects than there is in many of the ore formations. So it's unlikely that this is a result of mixing of two ore sources together from recycling in antiquity, right? This is because I'm getting essentially repeated identical values. These objects are tightly clustering, and this clustering would not be possible if you were just recycling things, because you would not get the same inputs as consistently. I believe what this represents is an as of yet uncharacterized copper ore source based on the age and some other signatures in the isotope, more than likely from this ophiolitic zone across Pakistan. These are a geologically related series of copper-bearing ophiolites of roughly the same age, and it's possible that this unclear source area matches one of these copper sources. I hope to be able to do more research on this in the future, either by myself or with colleagues, to kind of untangle this mystery. So what I believe is that based on the isotopic analysis of artifacts from the site of Harappa, is that copper sources in Rajasthan, Gujarat, Waziristan, and Balochistan are supplying the site with much of its copper. And we know that by the Harappan phase, right, the site had many trade connections with these areas. Here is a map from Dr. Law's research indicating all of the raw materials that are being imported to the site of Harappa from a variety of places that are similar to the places that have copper resources. So it's possible that copper was imported along the lines and through established networks. I want to then use this idea of an Indus signature again to look at copper and bronze artifacts from other third millennium Bronze Age societies across the region to see if we can identify possible Indus copper and bronze in these areas. Again, this is relying on this idea of an Indus lead isotope signature. Zooming in on this a bit, and I put here a variety of Mesopotamian, right, from Mesopotamian sites copper and bronze objects. Many of the Mesopotamian copper and bronze objects have been securely provenienced to sources from that region. However, there is a number of objects where researchers working at Mesopotamian sites are uncertain of where they come from. Previous researchers have hypothesized that these objects must have been made from very old rocks, very copper hosted in very old rocks. Looking around at regional geological evidence, they hypothesized that possibly it was coming from sources in southern Rajasthan. I can now say that the evidence indicates this is a distinct possibility. In fact, there is an isotopic correlation of a significant number of bronzes from Mesopotamian sites with copper in the Aravalli range. What's interesting is this copper and bronze that correlates with Rajasthan or Indus signature is coming from Mesopotamian elite context. It's coming from things like royal cemeteries and tombs. It suggests status and wealth. And it makes me wonder and hypothesize that perhaps Indus bronze was a valued material and functioned as a status or elite import. What's interesting, if we look at objects from Oman in the UAE, only a small number of objects fall into the Indus box. But again, these objects come from status context. They come from Umayyad period tombs at Tel Brak, and it may indicate that there is a correlation with sources not only in Rajasthan, but sources in Baluchistan as well. So we see that the Indus signature is present in some of the adjacent third millennium bronze-using cultures, but not all. For instance, it's missing so far in the data sets available from Iran. It's missing from sites in Dilmun, but it's present in Mesopotamia and portions of what is referred to as Magan, but not other portions. So within the Indus, we see copper and bronze used extensively in both utilitarian and status goods. The major form of Indus supply was met and obtained from a variety of South Asian sources. There is some importation of copper from Omani sources, but there is also exportation of copper and bronze to Mesopotamia. In contrast, the UAE and Oman sent copper to Mesopotamia. They used primarily local supply, but there was a limited Indus signature, but it only occurs in prestige context, perhaps signaling that it was not so much an importation of raw materials or copper and bronze to supply needs, but more of a status symbol to import or have materials or items from a distant trading partner. We see no Indus signature in Bahrain. And again, we know that Bahrain is supplying copper to Mesopotamia. So we see that Mesopotamia is sourcing its copper raw materials from a variety of sources. We know that bronze is a prestige and status good within those societies, and perhaps Indus material functioned within that status and wealth hierarchy. Returning specifically to copper and bronze metallurgy at Harappa, the present data suggests that for decorative objects, alloying practices were driven by the visual appearance of the finished objects. Items meant to be displayed required production through specific copper alloys to achieve a pre-selected final product. In contrast, tools or more utilitarian objects do not appear to conform to any set pattern of alloy usage. The functional purpose was the driving factor behind the alloy, and however that was accomplished was fine as long as the final product performed as desired. So we see that sites such as Harappa must have been engaging in trade and interaction to obtain the necessary raw materials to make a variety of copper and bronze artifacts. These raw materials appear to be obtained from larger South Asia and Oman. They then traded out copper and bronze to Mesopotamia. There's no pattern to alloying by artifact type or spatial location. In other words, alloy use was not restricted to specific areas or only for the use in specific types of object. Production occurred in multiple locations at Harappa contemporaneously, and there's evidence for all aspects of production, from smelting to final product. Copper and bronze must have functioned in wealth and status hierarchies at Indus urban sites such as Harappa. It was used in items of personal ornamentation, but it also functioned in non-wealth and status hierarchies as well, because it was used to make utilitarian items such as tools that would have been used in daily tasks and to accomplish basic purposes. Apparently, to date, evidence for control of production at Harappa appears to be decentralized and relatively unrestricted. I thought I'd finish with some future directions and some intriguing examples of copper and bronze metallurgy from the Indus. This is one of my favorite objects, where we have a disc that appears under low power magnification and XRF analysis to be made of two different layers. This layer is unalloyed copper, while this is a layer of copper, tin, and lead alloyed together. And what you can see is this creates two distinct visual appearances. And I believe the alloyed side was the side that would face out and been meant to be displayed, whereas this portion was not meant to be displayed, and so it wasn't made of alloyed copper with a distinct visual appearance. We need to do more somebody needs to do stylistic studies to determine if Indus style bronzes, those were the Indus signature, were they trading Indus style objects to Mesopotamia, or was the copper raw materials coming in and then Mesopotamian style objects were being made? It's not clear what was analyzed and what the best fit is. In addition to stylistic studies to determine if local production was using Indus raw materials or finished goods were what was being traded, additional ore geology would be helpful. This research is ongoing and hopefully can begin to help untangle more about the signatures of the different areas in the Aravallis. One of the things is there's reported utilization dating back to the Harappan times of tin deposits, particularly those around the Tosham Hills. And more research needs to be done on that to see if that could be a source of the tin that was being used in the Indus, in addition to or in substitution thereof of previously hypothesized sources across Afghanistan. Additional samples need to be looked at from third millennium sites in Oman to try to answer the question of why other exchange networks were happening, but not copper and bronze. So one of the things that can be done is you can use the same kind of isotopic approach on a different set of isotopes, primarily tin isotopes, and you can source the tin that is in these alloyed artifacts. So that could be a further avenue of research to see if sources were coming from India or Afghanistan or other places as well. This is a technique that has yielded success in other regions of the world. Metallographic studies would be useful to see if there's an Indus metalworking signature. This would help determine if Indus goods were being exported as finished products or as raw materials. That is the end of my presentation.